Hello and welcome to today's session. My name is Dmitro Polishchuk, and this is our next DBT Talk expert session. And this time it is related to snapshots in DBT. For those of you who are new, I would like to say a couple of words about DBT Talk Hub and Speak. We make these sessions on the first Thursday of every month, where we discuss various topics related to transformation tool DBT, as well as DBT Cloud and DBT Package Data Vault for DBT, made and supported by scale-free developers. I do these sessions in turns with my colleague Aaron Revale. And if you would like to have a DBT session on some particular topic or functionality in the future, you can send your questions up front by filling out a form on our website, scalefree.com/dbttalk. So let's start. A few words about myself. My name is Dmitro Polishchuk. I'm a senior BI consultant here at ScaleFree. I've been working for ScaleFree for more than 2 years. In general, I have experience in data warehousing and business intelligence since 2017, in particular in consulting and implementation of data warehouse BI solutions for different industries, retail, digital, finance, and others. From the educational side, I did a bachelor in finance and financial management. And then I also did some further certifications. The most relevant of them are CDVP2, Certified Data Vault 2.0 Practitioner. I have a Microsoft certification related to data engineering on Microsoft Azure. Additionally, I have a Snow Pro Core certification. And the latest one is the certification related to DBT Cloud Administration. My core competencies in data warehousing are data engineering, Data Vault 2.0 modeling, Data Vault automation, and also dimensional modeling. So let's start. What is a snapshot in DBT? A snapshot in DBT is a tool that captures and preserves changes in data for tables that may be updated over time. By taking snapshots, we create a record of each state a row has been in, which would be otherwise lost. Snapshots are essentially act as a history preserving feature. Snapshots allow us to look back and see what a row looked like at previous points in time. This is particularly valuable when working with mutable tables, which often serve as source tables in DBT, where data points like statuses or attributes might be updated frequently, and we need to analyze or report on historical states, not just the current one. Snapshots in DBT are built on the concept of type 2 slowly changing dimensions, which track the history of changes to each row. This means we not only see the current state of data, but also have record of each previous state, along with timestamps showing when each version was valid. This enables us to know when changes happened and what those changes were. A common use case for snapshots is tracking fields like status of an order in an orders table. For example, an order might move from pending to shipped or to delivered over time. And with snapshots, we capture each status change, allowing to analyze the life cycle of orders over time and see how long they spent in each status or even investigate past order trends. The snapshots are essential for scenarios like auditing, where we need a reliable record of data states, regulatory compliance, where a history of changes may be legally required, and historical analysis, where we want to understand how data evolved over time. Snapshots make these insights possible without needing to alter the source systems themselves. So how snapshots work in DBT? The snapshots are run with the command dbt snapshot. Snapshots are also a part of the dbt build command. It is important to note here that snapshots cannot be rebuilt in the direct way in dbt, meaning that you cannot run dbt snapshot with the full refresh option. And if you run dbt build with the full refresh option, it will not rebuild snapshot. And this is by design to prevent accidental deletion of the valuable historical data. And in order to rebuild or reload the snapshot, you have to truncate or drop the target snapshot table directly in the database. Another way would be to implement a custom macro in dbt that would send these commands to the database. So upon the first run of a snapshot, dbt creates an initial snapshot table from your select statement. No checks are done at this stage. dbt just adds metadata columns like dbt valid from and dbt valid to, whereas all values in the dbt valid to column are set to null. There are also two additional metadata columns added to a snapshot, like dbt SCD ID. This is a unique record key generated for every record by dbt, and dbt updated at. This is a timestamp of the record insertion. And upon the next runs, dbt checks for changes or new records in the source table, whereas it updates dbt valid from column for records that have changed and inserts updated records and new records with dbt valid to sent to null. And metadata column names for snapshots like dbt valid from or dbt valid to can be customized. This feature is available starting from dbt version 1.9, which is in pre-release right now. However, the new version contains some further improvements for snapshots, which we will review on a separate slide. Snapshots can be referenced in downstream models using the ref function, just like the standard dbt models. How dbt detects row changes over time? dbt offers two snapshotting strategies to do this: timestamp and check. The timestamp strategy relies on an updated add column. This should be a timestamp column that is often already present in many data sources. When the timestamp changes, dbt captures it as a new version, and only rows with the new timestamp changes are updated or inserted into the snapshot table. The timestamp strategy is recommended in dbt because it is straightforward and highly performant. It only captures a change when the timestamp value changes, reducing unnecessary column comparisons and simplifying the process of identifying modifications. It's especially effective for tables with frequent updates, as it minimizes resource usage since only one single column updated at is checked. On the other hand, the check strategy is useful when there is no reliable timestamp column in the source. Here, dbt compares specific or all columns in each row, depending on a snapshot configuration, and updates the snapshot record if any of these columns differ from the previous version. It's flexible, but can be resource intensive for tables with many rows or columns, as each comparison adds processing time. Changes for both strategies are detected over a unique column set in the unique key setting. You have to make sure that the unique key column is really unique. Otherwise, dbt may not detect updates accurately, leading to unpredictable results in your snapshots. If you are snapshotting a source, dbt recommends adding uniqueness tests to the sources. dbt also allows optional tracking of hard deletes by setting invalidate hard deletes. There's a special setting for that to true. This feature is not enabled by default. With this setting enabled, if a row is missing from the source data, dbt will update its dbt valid to timestamp, marking the record as no longer valid, allowing for full data integrity over time. Let's have a look at how snapshots can be configured in dbt. All snapshots have to be created in the directory named snapshots, if not configured otherwise. Different folder name can be also set in the dbt project YAML file. In version 1.8 and earlier, snapshots have to be defined in a SQL file within a block snapshot, where you can also use the config block for further configurations. You can set all or additional configurations in a YAML file. And of course, you can configure snapshots in the dbt project YAML file for some setting to be applied for all snapshots, like target schema, database, snapshotting strategy, or even custom column names. If same for same strategy, for example, if same strategy to be used for all snapshots in the project, for example. And starting from version 1.9, YAML-only configuration is supported, meaning that you no longer need a separate single SQL file. We'll have a closer look at different snapshots configurations during the demo session. As was mentioned earlier, DBT version 1.9 introduces some improvements for snapshots, which we're going to review on this slide. As was just mentioned, starting from version 1.9, you don't have to create a SQL file defining a SQL statement for a snapshot. You can fully configure a snapshot in a YAML file where you define all settings, including a snapshot source relation. Like was also mentioned before, with the new version of the snapshot method with the new version, the snapshot metadata column names can be customized according to your needs. The next improvement is that the target schema or just schema setting becomes optional in the new DBT version. If omitted, DBT uses the environment's schema by default, just like DBT does for DBT models. In version 1.8 and prior, target schema was a mandatory setting. Now snapshots support settings like database and schema, like other DBT resources. Previously, the names of the settings were target database and target schema accordingly. And last but not least, in the new DBT version, DBT will generate a warning if the updated add column doesn't have a correct data type, enhancing data integrity. And on the last slide, I would like to talk about the best practices for snapshots recommended by DBT. First of them is that you should always use separate schema for snapshot. So not always, but it's recommended by DBT to use a separate schema for snapshots so that they are isolated from other DBT models. As you already know, snapshots cannot be rebuilt by design to prevent unintentional deletes of the historical data. So putting snapshots in a separate schema makes unintentional deletes even harder. Additionally, you may want to set a different privilege for the snapshots, and separate schema would allow to do that. You should prioritize capturing source data in its raw form. Prioritize using source function in your snapshots queries. Whenever makes sense, aim to include all columns in your snapshots to ensure future flexibility. Consider the potential value of even seemingly irrelevant columns. Avoid joins in your snapshot queries. Better separate the tables into individual snapshots and join them in your models downstream. That will simplify the tracking of updates and changes. Limit transformations. Keep snapshot queries as straightforward as possible, focusing on data capture rather than complex transformations. And when you still do need some transformations, use ephemeral models to clean and transform data before snapshotting, and then snapshot ephemeral models. This can be especially valid for YAML-only snapshots introduced with version 1.9. Schedule snapshots to run frequently. This is one of the most important points. Here, I would say snapshots make sense when running regularly. This way, you can capture data changes at regular intervals. And now it's time for the demo session. I will stop sharing my screen for a moment to set up everything. Okay, so for this demo, I prepared 3 tables that will serve as a source for DBT snapshots. Customer with last updated. So basically, there is a demo source, a schema, where that contains this source tables. The first of the tables is customer with last updated. So let's check how this table looks like. So basically, this is a simple table listing the customers and some attributes. And this table contains last updated, as the name of the table suggests. And this table, so we will configure snapshots, a snapshot for this table using the timestamp strategy. Then the second table is customer no last updated. So in this table contains no timestamp column. So this table will be used to showcase the check snapshotting strategy. And the third table is orders. The feature of this table is that it doesn't contain one single unique column, but rather two columns that uniquely identify a row, namely order key and part key. So I will show you how you can configure a snapshot for a table without a single unique column. And now let's look at how snapshots are configured for these tables in the demo project. So here is our demo project. For this demo, I configured several snapshots as it was done in version 1.8 and prior, and several snapshots for version 1.9, highlighting some changes that were introduced for snapshots in the newest version. But I would like to start with snapshots in version 1.8 and prior. Let's look at this snapshot, customer timestamp 1.18. So the snapshot is defined within a snapshot block. And inside the snapshot block, you can see the select star statement where we just simply select all columns for our source customer with last updated. And let's look at the configuration to the configurations to this snapshot. They are located in a separate YAML file. The strategy is set to timestamp. Unique key is our customer key, and updated at column is the last updated column. Invalidate hard delete set to false, which is the default value. I will change it later. And yeah, so the next snapshot is customer check 1.8. Here, the config block is defined within the snapshot block, not in a separate YAML file. Strategy is set to check. Unique key is our customer key, the same way as in the previous snapshot. And check column setting is set to all. Alternatively, you can set the list of columns as an array. So with this setting set to all columns will be compared for and will be checked for changes. If you want to skip some columns, or if you want to have some particular list of columns to be checked, you can set you can list them in an array and put it directly here. And yeah, this snapshot contains this simple select statement as well. And the last snapshot is made and configured for table orders, timestamp 1.8. And this snapshot contains the configuration inside the snapshot block as well. Timestamp strategy is set, and the unique key is set to order part key, which is our calculated column. Remember that this table doesn't have one single unique column, and here I defined one directly in the select statement, concatenating order key and part key columns. And the newly created column is set as a unique key here in the snapshot configuration. And additionally, I have one additional configuration for a snapshot in the YAML file. Here I configured schema name snapshots. So our snapshots should be created in this schema. So let's, additionally, what I would like to point out that I configured tags for our snapshots, and I will use this tag 1.8 to run all the snapshots configured for version 1.8. So let's run our snapshots. I will just copy and paste this command. This command was actually here. Let's run our snapshots. Okay, our snapshots were successfully created. Let's have a look at them. So as you can see, with the first run, as was mentioned during our presentation, with the first run, no checks are done. The BT just executes a select statement and adds four metadata columns to a snapshot. And so basically here are our metadata columns, and for all records, the BT valid 2 is set to null. Let's check in the second column. So basically it doesn't differ from, sorry, this is the one. It doesn't differ from the customer timestamp, with the exception that this table doesn't have any last updated column. And here is our last orders timestamp, snapshot for orders timestamp. And this is the calculated unique key column. And everywhere dbt valid 2 is set to null. Now let's do some updates. So the first update that I would like to do is for customer with last updated. I'm going to change customer name for our customer 601. So I will simply execute this update statement. But since this table contains last updated and this snapshot for this table is configured for the timestamp strategy, I also have to update get date. Otherwise, the snapshot will not detect any changes. So I will just update our customer name, and that's in our source table. Let's check. Here you can see that our customer was updated with a new name. And let's run this snapshot and look at the results. I'm running this dbt snapshot command, begin our table. Okay, was detected some changes. Let's check them. Okay, and as you can see, this is our snapshot table. And now it has two entries for the customer key that we updated. The one entry is with the old value for the customer name attribute. And for this row, dbt valid 2 was set to the timestamp, to particular timestamp. And a new row was inserted with the new attribute value with the valid 2 set to null. So this is basically how it looks like. Now I'm going to update another source table, customer no last updated. Snapshot for this table was configured with for the check strategy. So I'm going to update, execute the update, and then let's check that our source table was successfully updated. Here, our customer was updated with a new name, and I'm going to run snapshot for this table. Okay, let's check the result. And here you can see basically the same result as with the previous snapshot. So the change was detected by DBT. And here we have two entries for the customer 601. The row with the old attribute name was closed, meaning that DBT valid 2 was updated with the current timestamp, and the new entry with the new attribute value was done for this for our customer. And now let's check what will happen if we delete a row from a source table. I'm going to delete the customer with ID 610 from the table customer with last updated. Now let's run this. So deletion was done. And I'm going to run the snapshot again. Okay. And let's check our snapshot. Here you can see that the customer key, so our deleted customer is still present in the snapshot table, which is okay, but the BT value 2 was not updated. And to to enable that, we need to basically to make our snapshot update DBT valid 2. I have to change the invalidate hard deletes setting and set it to true. Now, when I do that, and when I run our snapshot again, then we will see that DBT detected some change. And if we have a look at our snapshot again, you will see that DBT valid 2 was updated with it with the current timestamp. So now with this setting enabled, we can simply filter out rows and check rows that were deleted, and in this way we know when the row was deleted, enabling for the full data integrity. And now let's check what will happen if a source table has some structural change, like deleting or updating or deleting or inserting a new column. To test this, I'm going to rename column comment in the table customer with last updated. I'm going to rename column comment to comment new. In this way, I will emulate deletion and addition of a column, and then I will let the snapshot run. So I will alter the table. Let's check. So you see that comment new, our comment table was comment column was renamed to comment new. And let's run the snapshot. So let's check the result in our snapshot, how snapshot reacted to this change. So here we can see that we still have the old column comment, and DBT detected the new column and inserted it, appended it to the end of our snapshot table. But the values are set to null. This is because I haven't updated any values. Now, if I update our column new column in our source table for our customer key 609, then DBT will start reflecting changes in the new column. So I will let's check that our new column was updated. So here you can see that. Now I'm going to run our snapshot for this table again. Okay, and let's check the result. And here it should have been updated. The comment new, it should have been catch this change. Just a second, I will run it again. Yeah, I executed the run SQL statement. Here you can see that dbt started populating a comment new column with new values, but the old column comment is the values for this column are set to null. So as you can see from this from this example, dbt handles the structural changes for snapshot for source tables that it snapshots quite gracefully. And the last point that I would like to show you is snapshots and how they are configured in version 1.9. Here I highlighted some improvements made in the new version. So it's YAML only configuration, meaning that no more extra SQL files required. Source relation specified directly in the YAML file. And here we have setting relation, and we specify what should be snapshotted. So the relation that should be snapshotted. The schema setting is no more required for snapshots, although I set it in dbt project YAML. But if I remove this schema, then dbt will just put all the snapshots and build all the snapshots in the schema, in the same schema as other dbt models. And snapshots metadata column names are now customized, so we can set different names in our for our snapshots. And for the snapshot for orders, remember that the source table doesn't have a single unique column. So the orders doesn't have a single unique column. So in this particular snapshot, I'm referring to not to the source directly, but to the ephemeral model orders. And inside this ephemeral model, orders, I calculated this unique key column. And then here I set it as a unique key. Yeah, so basically this is how dbt recommends doing that. And now let's run our snapshots for version 1.9 and look at the result. Okay, let's check what we will have here. Okay, in the customer timestamp 19. So what I would like to show here is that now our metadata columns in this snapshot have custom names, and as well as in the orders, in snapshot for the orders table. Yeah, and these are our order part key that we calculated in an ephemeral model. So this was it for the demo. I will stop share my screen for a moment to set up slides. Okay, just a small recap. In this session, we covered the essentials of dbt snapshots and their role in tracking changes in mutable source tables over time. We explored how snapshots are defined, configured, and built in dbt. Then we look at the latest enhancements introduced in DBT version 1.9. We also discussed recommended best practices for efficient snapshot management. And to wrap up all that, I provided a live demo showing how to create, configure, and run DBT snapshots, highlighting their particular use in maintaining historical data. I also would like to mention that Scale3 has a variety of trainings available. Some of them might be relevant for your projects. For instance, we have one related to DBT and Data Vault 2.0. In this training, you will learn DBT even if you don't have any experience with this tool, and also Data Vault 2.0, which is one of the main areas of our expertise here at Scale3. So I think this training may be the best combination for those who would like to learn Data Vault 2.0 methodology together with the tool for its implementation. Additionally, we have other trainings, the one related to Data Vault 2.0 automation with Veriscape, for those who are interested in working with the Veriscape tool, which is one of the alternatives to DBT. And finally, the one related to the agile data warehousing and the example of how it's applied to the development of Data Vault-powered enterprise data warehouse. The training is relevant for those who would like to apply agile development in their data warehouse projects to bring them on a new level. So go to scale3.com and check those trainings if you are interested. Yeah, that was it for this presentation. Go to scale3.com/dbttalk and register for our next webinars. If you would like to have a DBT session on some particular topic or functionality, you can send your question up front by filling out a form, which can also be found there. Thanks for your attention. See you in our next session. In our next sessions. Bye.